Hello everyone. We learned last lesson how to use the geological compass to measure the three elements of attitude. After we measure the attitude of rock mass joints and bedding, how should it be applied? Today, we will learn together how to draw a joint rose diagram. Joints, also known as fractures, refer to small-scale fracture structures, where rock blocks on either side of a break in a rock mass do not have significant displacement after being subjected to force. Both joints and faults, which we have previously studied, belong to the category of discontinuities. The difference lies in the fact that rocks on either side of a joint do not have significant displacement, whereas rocks on either side of a fault have undergone obvious relative movement. By statistically analyzing the density and orientation of joints, we can intuitively evaluate the strength, stability, and permeability of the rock mass, which is beneficial for the collection of stone materials and helps us explore the laws governing the occurrence and development of large-scale tectonics. Joint statistical diagrams clearly and visually represent the attitude of various sets of joints. Within a surveyed area, common types include joint rose diagrams, joint pole diagrams, and joint isodensity maps. Among these, joint rose diagrams can be further divided into joint strike rose diagrams, joint dip direction rose diagrams, and joint dip angle rose diagrams. The most commonly used type is the joint strike rose diagram. Now, let's learn the steps for drawing a joint strike rose diagram. Step 1. Data preparation. We need to convert the strikes of the joints counted into northeast and northwest directions. This is because the strike is a straight line, meaning it extends in two directions, so it can only be described as east-west, north-south, northeast-southwest, or northwest-southeast strike, but not simply as south, north, west, or east strike. To simplify the plotting process, we can plot within a semicircle, converting all strikes to the northeast and northwest quadrants. Step 2. Divide the semicircle into intervals, typically every 5 to 10 degrees. Group the joints according to their orientation, count the number of joints in each group, and enter them into a table. For instance, here is a joint tally table from a dam site. It shows that the number of joints with strikes between 41 and 50 degrees is 35, while the highest number, 50, falls within the range of 321 to 330 degrees. Step 2. Determine the scale of the rose diagram. Based on the size of the plot and the number of joints in each group, determine the segment scale, then draw a semicircle with a radius slightly longer than the longest line segment, representing the largest number of joints in one group. Finally, draw the north and east-west lines through the center of the circle and mark multiples of 10-degree azimuths around the semicircle. Step 3. Locate points and connect them. Mark or draw auxiliary lines at the semicircle corresponding to the average or median values of the azimuths of each group. For example, draw an auxiliary line at 45 degrees for the interval between 40 and 50 degrees. From the center of the circle toward the circumference at this point, find the points based on the number of joints in that group and the established scale. And then we start from the center of the circle. For instance, if there are 35 joints between 41 and 50 degrees, you can obtain the length of the corresponding line segment according to the scale and project this length onto the auxiliary line to locate the point. Then, using the same method, determine the points for each group and sequentially connect the adjacent group's points. Note that if the number of joints in any one group is 0, then the line should return to the center of the circle before connecting to the next group. Next, to understand the dip direction and dip angle of the most developed set of joints, extend the strike of this set of joints radially beyond the semicircle. Here students should note that if the number of joints in any particular group is 0, the line must return to the center of the circle, and then lead out again to connect to the next group. Finally, Always make sure to check the title and scale of the diagram. The title and scale are usually placed in the center, below our graphic symbol. Now, in order to understand the dip direction and dip angle of the most developed set of joints, we can extend the trend of this set of joints along the radius beyond the semicircle. Divide the scale into increments such as 0 degrees, 30 degrees, 60 degrees, and 90 degrees, representing the dip angle, and then draw tangents, T direction of which represents the dip direction. We've just reviewed that the dip direction and strike are perpendicular to each other. So, taking this most developed set of joints as an example, it has two dip directions, southwest and northeast. Next, we also need to establish a scale to determine the ratio of line segments. Then simply count the number of joints in different dip angle intervals for this set of joints. At the base of the dip interval, draw triangles with the dip angle interval as the base and the number of joints as the height to create a schematic representation of the dip direction and dip angle of this set of joints, as shown in the right figure. The strike range of the most developed set of joints at a particular dam site is from 321 degrees to 330 degrees. There are two sets dipping northeast, where there are 25 joints with a dip angle between 21 degrees and 30 degrees, and 10 joints with a dip angle between 71 degrees and 80 degrees. There is only one set dipping southwest, with a dip angle between 51 degrees and 60 degrees, with a total of 15 joints. The above is the method for drawing a joint strike-a-rose diagram. We can use the same method to draw a joint dip direction rose diagram. Note here that the dip direction is a ray. Its angle ranging from 0 degrees to 360 degrees, so we need to project onto 4 quadrants, meaning we use the entire circle as the base for the drawing. So, when drawing the joint dip angle rose diagram, remember that from the center of the circle to the circumference represents 0 degrees to 90 degrees, and the other connection methods are consistent with the joint trend and dip direction rose diagrams. Note that the dip direction and dip angle rose diagrams are generally overlaid on the same chart, distinguished by different colors or lines. The above is the method for drawing joint trend, dip direction, and dip angle rose diagrams. Have you all mastered it? In actual work, it's often necessary to combine joint rose diagrams with regional tectonics. By plotting joint rose diagrams on geological maps, we can see more intuitively the distribution and characteristics of joints in different tectonic parts, further analyzing their relationships with other geological structures, such as folds and faults, helping us gain a deeper understanding of the stability and deformation trends of geological bodies. For example, take this geological structure map of the Amay Depression Fault Mountain in Sichuan Province, which has 10 rose diagrams plotted at different locations. I also hope that those of you in front of the screen can practice more and analyze real cases. Through constant practice and learning, I believe everyone will gradually become proficient and master this skill, laying a solid foundation for future engineering geology work. In this lesson we learned how to draw a boxing rose. Produced joint rose diagram can clearly reflect distribution of rock mass joints in a certain area. If we want to know more, rock formation and distribution characteristics, how do you show it? Next lesson we will study together the drawing method of geological profile.